Hi everyone. In this video we are going to talk about the rule of divisibility by 3. And the rule says that if you have to check for a number to see if the number is divisible by 3, then you can quickly calculate the sum of the digits, and if that sum is divisible by 3, then the original number also should be divisible by 3. That's what the rule says, right? So let's take an example. Suppose in our example we have a number which is, let's say, 123. That's a number, right? Now maybe we can quickly do a division in our mind and find out that yes, this is divisible by 3. You can easily see that this will be 41 times 3. That is 123. So this number is divisible by 3. But based on the rule says that the sum of the digits. So let's do the sum of the digits. In this case, it will be 1 plus 2 plus 3, which turns out to be 6. We all know that 6 is divisible by 3. So if the rule is actually valid, if the rule is true, then if I create another number using the same digits, for example, I create another number using the same 3 digits right here. Let's say suppose 321, right? So this is another number that I quickly formed using the same digits, and in this case also the sum of the digits will be 6, because it will be 3 plus 2 plus 1 is the same set of digits. I have not used any other digit, it's the same set of digits. So in this case also the sum of the digits is equal to 6, which is divisible by 3. So that means this number is divisible by 3, and this other number that I created, that is also divisible by 3. And if we try one other number, maybe let's say suppose 231 for example, right? Let's create a number 231. Now is this going to be divisible by 3? Yes, of course it will be, because in this case also the sum of the digits will be equal to 2 plus 3 plus 1, which is again 6. That means the number also should be divisible by 3. So looks like the rule is working. But is it just a magical rule, or is there some sort of a mathematics working behind the scenes? Well, let's find that out. Suppose, now what I'm going to do, I'm going to use algebraic symbols instead of the arithmetic digits, right? Instead of the decimal digits, I'm going to use the algebraic symbols for the digits. So suppose we have a number that looks like this. Suppose we have a number that looks like this, A, then B, then C, like how we have 1, 2, 3. Here, instead of using the digits, I am using algebraic symbols A, B, C. Now, if this is my original number, then this number is actually equal to the place value, the sum of the place values of these digits, right? So, what is the place value of A? A is in the hundreds position, so A's place value will be 100 times A, plus what is the place value of B? Well, B is in the tens position, so the place value of B will be 10 times B. And what is the place value of C? Well, C is in the ones position, so it will be 1 times C, which is C. Now, if you look at these 3 terms of this number, the 3 terms whose sum make up our original number, if you look at each of the terms, they don't seem to be divisible by 3. Neither of them, right? I mean, 100 not divisible by 3, 10 also not divisible by 3, and C also not divisible by 3. We really don't know what we have in C. So at least from a coefficient point of view, we can say that yes, C is also not divisible by 3. So then let's try to, split each of these terms, like this term and this term. Let's try to split them into 2 terms so that at least one term will be divisible by 3, right? So let's try that. Suppose now I'm going to split it into 2 terms here. The 100A, I'm going to write it as 99 times A plus one more A. That makes up the 100A, right? Similarly, the 10 times B, I'm going to write it as 9 times B plus one more B. That equates to 10 times B. And plus C. For C, I really cannot do a whole lot, so I'm just going to keep it as is. Now from here, I'm going to group these terms here, the 99 times A plus 9 times B. I'm going to group them together, right? And then I'm going to group the remaining ones, like the A and the B and the C. I'm going to group them like this, A plus B plus C. Now from here you can see that within the first parenthesis, the 2 terms that we have, each of them is divisible by 3. So let's take 3 as a common factor out, then that would leave 33 times A and 3 times B, right? Plus our remaining A plus B plus C. Now let me scroll down a little bit. Now from here we can say, okay, so this is 3 times some integer, because 33 times A plus 3 times B will also give us some integer. So let's say this is 3 times K, for example, right? Let's say this is 3 times K, plus we have A plus B plus C. So far we have been able to create one part of the number which is divisible by 3, but the other part we don't know. Now if we impose a condition here that if A plus B plus C is also divisible by 3, if we make this assumption, or we use this assumed condition that if A plus B plus C, this sum is also divisible by 3, we can possibly write it as maybe 3 times some integer, 3 times m maybe. So with that assumption, our number now is going to look like this. It will look like 3k plus 3m. Right? So from here we can say this is equal to, now let's take 3 as the common factor out, so it would be k plus m. Again k plus m, k and m they being some integer, so this is also equal to 3 times some other integer. Let's say it is a p, maybe 3 times p. Now you see that our original number n is now looking like this. Our original number n is now looking like 3 times of an integer. That means our number is divisible by 3. However, we have to remember what was the condition, or what was the assumption. The assumption was that if A plus B plus C is divisible by 3, then we have been able to prove that our number is also divisible by 3. So that is the only required assumption, that if A plus B plus C, which is nothing but the sum of the digits, our number was ABC. So A plus B plus C is nothing but the sum of the digits. So I'm going to write it down here. It is the sum of the digits of our number, right? So if the sum of the digits of our number is divisible by 3, then we are able to show that our number is also divisible by 3. And that's the actual hidden algebra that's working behind the scenes for the divisibility rule for 3. I hope everything made sense. Thank you for watching. See you in the next video.